So now what I want to do is I want to show you on a weather map what that looks like. And this section would be very important, especially when it comes to forecasting upper level winds and high and low pressure systems in the future. So here when we take our previous example on our ridge out on the west coast, our trough down in the central plains, and then our ridge out towards the east coast, what you notice is here you have a deep trough over the central plains. Well, what's important is that if you take the bottommost portion of this trough, which is known as the trough axis, and you cut it in half, in meteorology, we like to say that our area of divergence is on the right-hand side, which these are upper level winds because this is a 500 millibar map. So if air is diverging aloft, that means it's converging at the surface. And so what does that mean? That means we have an area of low pressure that is somewhere in this black circle, and over on the left hand side of the trough axis we have our area of convergence, and so this would be convergence aloft, which means that it's diverging at the surface. So this would be our area of high pressure on the left hand side. And so why is it that convergence would be on the left hand side and divergence would be on the right hand side, or high pressure develops on the left side of a trough and divergence or low pressure is associated on the right side of the trough? So imagine this ridge and this trough and this ridge as being a hill. And let's say that here you notice that the winds flow parallel to these isobars. Well, imagine all these isobars are lanes on a highway and the isobars are cars, okay? And so imagine that you were a car and that you were traveling down this hill, and let's say it was rush hour traffic. Well, you're traveling down this hill, but you notice that there's a bunch of cars piled up here because the cars have to change direction as they bottom out from the bottom of the hill and they start to go up the hill again. So you have cars that are going really, really fast, and then they slow down as they get to the bottom of the hill, and then they go to the top of the hill here and they start to pick it up again. So you can imagine air that is converging or has to slow down as it gets towards the bottom of the trough. It has to slow down because it has to make this turn, and so you have to slow down to do that. And so this is why our area of convergence is on the left hand side. You also notice the isobars here. You see on the isobars over the ridge where I'm highlighting with my mouse, you see how the isobars are relatively spaced together, or I'm sorry, they're spaced apart. But here on the left side of the trough axis, you see here that the isobars are very, very tightly packed. They're much closer together, so that would indicate higher wind speeds because there's a higher pressure gradient. There is a smaller distance with a greater change of pressure, and so that's what makes a tighter pressure gradient. So back here is our area of divergence. So here on the right hand side, these are diverging winds. You see how all the isobars are really tight together on the left hand side, but then on the right hand side they spread out, and so you can see how the wind actually is able to diverge, or the air is able to diverge here. So this would be your area of relatively low pressure on the right hand side. So this is very important when we talk about evaluating upper level wind maps, and what we'll talk about later on with vorticity maps, especially when it comes to weather forecasting.